Okay, we've got a pneumatics question for us today, and this is a circuit that double acting cylinder punches a tennis ball, probably for returning. When either a lever or a push button is actuated, the double acting cylinder outstrokes. But it's an automatic system, so it then instrokes and then outstrokes and then instrokes continuously. It says complete the piping of the pneumatic circuit. Well, first of all, we've got the OR circuit down here between this valve and this valve. So we're looking at pilot air going into the shuttle valve from either OR, and then that pilot air actuating a 3-2, which in turn actuates the 5-2, which in turn outstrokes the double acting cylinder. Now at some point the double acting cylinder will instroke, and so it must be connected on both sides to the 5-2. However, let's have a look at how it instrokes. When the double acting cylinder outstrokes, it hits this roller trip. The roller trip then can send air, pilot, through a restrictor into a reservoir. When the reservoir fills to the correct pressure, pilot air is then sent to the double acting cylinder, and that completes the piping of the circuit. Next part of the question, state the full name of the two components, A and valve 1. Well, component A is a reservoir, there it is, and valve 1 here, well, it's a 3-2 valve, it's a pilot air valve, and it's a spring return. So it's a 3-2 pilot spring return. Okay, look at the second part of the question now. Here we've got the diagram of the cylinder that outstrokes and instrokes, and we're asked the piston below instrokes when air is supplied at a pressure of 0.5. So we've got pressure there, and we're looking for the instroking force. Okay, so it says calculate the force. Well, first of all, I've got two areas. I've got the area of the cylinder, and then I've got the area of the rod that comes out of the cylinder. So we'll call that area A, and we'll call that area B. So we're looking for the effective area of each of these. Well, the area is equal to pi r squared. The diameter is 30, so the radius is 15, so 3.14 times 15 squared. Over onto the calculator. 15 times 15 times 3.14 equals 706.5 millimeters squared. Now area B, a lot smaller, the same formula again, pi r squared, 3.14 times, this time 5 millimeters squared, so it's cancel, 5 times 5 is 25, times 3.14 equals 78.5. So we're now ready to find out the effective area, and it's equal to A minus B equals 706.5 minus 78.5. Put that onto Memory Plus. 706.5 minus Memory Recall equals 628 millimeters. Now we're only halfway there. We found the area. We now need to put into the formula for finding out the force. Well, the force is equal to the pressure multiplied by the area. So pressure is given to us as 0.5 newtons per millimeter squared, times the effective area 6 to 8 meters. Well, let's just divide that by 2. It gives us 314, and my units for this, because it's a force, newtons. Okay, last part of the question. Describe 2 ways of reducing the outstroking force applied to the piston. Now, a lot of people jump in here and say restrictor, but that's not actually the case. That just reduces the speed of the outstroke, not the force. The only way to reduce the force is to look at the force equation. Force equals pressure times area. So the 2 ways is to reduce air pressure in the system, and the second is to reduce the diameter of the cylinder. Okay, and that's that.